Hello again. We are continuing on with Unit 4, or Unit 1, it's going to be Chapter 4. Today's section, we're going to start with 4.3, which is factoring and solving. We're going to focus just on factoring first. Factoring, what I mean by factoring quadratic equations. So, number one, the first goal of this lesson, or I can statement, or I will statement, factor equations of the form x squared plus bx plus c. Factor equations with special patterns, aka difference of squares, and perfect square trinomials. So make sure that you copy these down at the beginning of section 4.3 in your notes, so that I know you have those as the main goals of the lesson and what you really need to be looking for as you go through the notes. So types of polynomials, and polynomial is a very wide range of possibilities, a large family of functions. But in this section, in this chapter, we're going to concentrate on just x squared polynomials and lower. So you can have x to the third, x to the fourth, and we'll get to that in chapter 5, but not in this unit. So monomials, what is a monomial? A monomial is a type of polynomial. A monomial has one term. It's a one-term polynomial. So we pick up on that. Mono, the prefix mono is 1. So one term. Examples of monomials: 3x, 4x, x, y. 1, if it's just a number, that's a monomial. 2, 0, 4, x, y. Those are monomials. Now notice, you're saying, well, there's 3 terms there, there's 2 terms there. No, they're being multiplied together. If they're multiplied together, that counts as one term. You say, well, if it's a fraction, if it's x divided by y, that can't work. That's not a polynomial. So, as many things you want to multiply together. You could have 10 terms multiplied together. 4, a, b, c, d, e, f, g, h, i, j. It's all multiplied together. It's a monomial, one term. We start putting pluses or minuses between terms. Now we're getting something other than monomial. So, a polynomial with 2 terms is called a binomial. The prefix bi, that means 2. So binomial, monomial is 1, binomial 2. Examples of binomial: x plus 2 is a binomial. Doesn't have to be in parentheses, so drop the parentheses. We're going to see it in parentheses a lot when we factor, but it doesn't have to be. X plus 2, 4x minus 7, 2x plus 3. These are all binomial examples. The key thing is there's one plus or one minus sign separating 2 monomials. Now they're all connected. And last but not least, if we have 3 terms, it could be 2 plus or minus sign combinations, it's trinomial. Tri is 3. Tricycle, triangle, 3. So a trinomial. You get crazy ones. 3x minus 5 plus y. There's a trinomial. 3 different terms. I can't combine any terms. That's a key thing too with the binomials. Somebody might say, well, what about 2x plus 3x? 2x plus 3x is not a binomial because I could add the x's together. So you should clarify that as it's something that terms cannot be combined. There's no like terms. I can't add x and y together with 5. Obviously, the x's or the y's are all different terms. Most commonly, you're going to see something like this: 4x squared plus 3x plus 1. You're going to see something written in standard form. A trinomial is basically a quadratic written in standard form. That's what the trinomial is. We're going to use factoring today to separate a trinomial into binomials and or monomials. But we have to know what the terms mean. So monomial, binomial, trinomial, here's examples of each. This is kind of the definition. So if you need more time, pause this and make sure you get these all down, the examples, and they'll help you as we go on in the lesson. So factoring trinomials, x squared plus bx plus c. And I'm going to go ahead and I'm going to put in a in front of that. ax squared plus bx plus c equals 0. And I'll show you why in a minute. Okay? So the method we're going to use is not a method I invented. It's a method that has been around for a while, but is relatively new. I did not know this method when I was in high school, which is not all that long ago to me, anyways, but I was not exposed to it. It's different than the way I look. I think it may seem confusing at first, but it's a way that you can factor any trinomial that's in quadratic form. So the method's called bottoms up. Okay, so the first step is find two numbers. First step, find two numbers that multiply to make a times c. And then two also have to add to make b. Where is a, c, and b coming from? You got it. A, B, C. Right up here in our standard form of the equation. So in order to factor a couple of things. One, today we're not going to solve an equation. A lot of times you'll see that equals 0. And if you're solving an equation just for down the road, it has to be set equal to 0 if you're going to factor. But factoring, all the terms must be combined. It must be in standard form in order to factor it. So this is what we're going to do. Here is our example. X squared plus bx plus 14x plus 48. We're going to factor this. We're not going to solve it. We're going to factor it today. We will solve it in a couple of days. I'll show you how to solve it. We're just going to start with the method of factoring. So something that multiplies a times c, our a is 1, our c is 48, and adds up to make 14. That's just a combination we're looking for. You can use your calculator, you can use times tables, but what multiplies to make 48 and adds up to make 14? Some of you say, well, Mr. Kuhn, how do you get this so fast? I don't get it as fast as you do. You just got to keep practicing. This is why you make a table. You list out all your combinations so you don't repeat. I did not do this when I was in high school. The other method for factoring is similar. So you look for numbers that multiply to make the c. Okay, that's what we learned in high school, or the a times c. But we didn't talk about adding to make b. So you look for different combinations. And I didn't write them down, and it took me forever. If you write it down, you'll systematically eliminate possibilities, and you'll eventually be able to narrow down what the value is, if it can be factored. There are trinomials out there that cannot be factored. So that is a possibility as well. But let's look and see if this one can. So let's start with what multiplies to make 48. Well, here's one that's given to me right there. 1 times 48. That multiplies to make 48. But does it add up to make 14? And I think the obvious answer is it does not. So this is not a combination. Okay? 1 and 48 for A and C, that does not work. Or instead of an X, that might be confusing. How about we put no? So we pick another combination. Okay, well, I guess I won't go over there as well. Another combination. It multiplies, numbers that multiply together to make 48 and adds to make 14. Well, let's see, does 2, it's an even number. 2 times 24. Well, 2 plus 24, that is 26, not 14, so it's another no. Does 3 divide 48? Take a minute on your calculator, see if 3. Hopefully you took a moment to see if it did. And you saw that 3 does divide 48. 3 times 16 is 48. 3 plus 16, that's closer. That's 19. That still does not work. Has anybody seen the pattern yet? How about 6 and 8? 6 times 8, that is 48. 6 plus 8 is 14. It identified both. We have a winner. We have a winner. 6 and 8 are the values that work. So does that mean it's just factor 6 and 8 is our answer? No, not exactly. Okay, but it does give it points in the right direction. Because when we factor this, it's going to be x plus something or x minus something and x plus something and x minus something on the other side. Now, How do I know in this case it's both pluses? In our original problem, both signs were positive. So that's the only combination that's going to work, as you'll see in a minute when we check it. So x plus 6, x plus 8. Here's the bottoms up part. Okay, because remember you're going to take a trinomial, and you factor the trinomial, you try and get it into two binomial terms. Here's the bottoms up part. Identify what A was. So write this out, bottoms up. A was 1. So we're going to divide each factor by A. This is for every single time. Why am I having you practice this with this one? Because you're going to see we don't really need it for just x squared plus bx plus c. But if you practice it now, it'll be second nature when we get to the more challenging ones, where A is a number other than 1. So what we do is we write out the expression that we just found, x plus 6 and x plus 8. And we divide 6 and we divide 8 by 1. We notice 6 divided by 1 is 6. So we just leave it. We notice that 8 divided by 1 is 8. So this is the factored form, basically reversing FOIL. We just reversed FOIL to go from a trinomial, x squared plus 14x plus 48, to these two binomials being multiplied together. So we just take our word for it that that's it. If it's reversing FOIL, then we should be able to check. I'm just going to check really quick with the box method. If you like FOIL, you use FOIL. A lot of people out there that struggle with multiplying binomials, the box method helps them. So the more practice with that, the better they're going to get. If you're already good at FOIL, then you keep using FOIL. X times x is x squared. X times 6 is 6x. 8 times x is 8x. 8 times 6 is 48. And we write out our like terms and line them up. We end up with x squared plus 14x plus 48, which is what we started with. It checks. It checks. That's our answer. That is factoring using the bottoms up method. Now, something I did not mention at the beginning, you always want to look for is a monomial term, something that you can divide all your terms. So you always want to check that, and we'll go with that first, because you cannot do bottoms up unless you pull out any terms that may be a common factor out of all three terms. But the common factor for x squared plus 14x plus 48 was 1. I just assumed we all saw that, but I might want to point that out to you now in case you're wondering in the future why we're dividing out something before we get started with bottoms up. So let's try another example. This time, let's use the equation r squared plus 2r minus 63. Remember, our variables could be r's, h's, k's. It doesn't matter what our variables are. X's, so let's shake it up and let's use R. Let's be wild and crazy. If we look, check, like I mentioned on the last slide, make sure there's nothing that can be divided out other than 1. The greatest common factor is 1, then we're good. Obviously, there's a 1r squared. 1's the only thing that's going to divide. The only thing you might check is sometimes there might be an r term in all three of them that you could divide out. I don't see that. 63 doesn't have it, so there are no monomials to pull out. So we're going to go straight to bottoms up. In bottoms up, remember, in bottoms up, we make our table. We say, what multiplies to make A times C? Well, A times C is 1 times negative 63, or negative 63. And what sums or adds to make B? B is 2. So what's something that's going to multiply to make negative 63 and add to make 2? So we make our table. Well, it's negative, so positive 1 and negative 63. Does that work? And the answer is obviously no. And neither does negative 1 and positive 63. But that is a different combination. So the bummer when C is negative is you have to try double the amount of combinations, because flipping the negative sign usually gives you a different sum when you add them together. So we go through this, Try and think of other numbers that multiply to make 63. Well, 7 and 9 does. Let's try positive 7 and negative 9. So positive 7, positive 7 and negative 9 add to make negative 2. That's not it, but that's cool because it's pretty close. So now if we flip the negative signs, negative 7 plus 9 is positive 2. Yes, we have a winner. Winner, winner, chicken dinner, the old Vegas saying goes. So, we have a combination. This is the one, negative 7 and 9. Our variable was r, so that's what I'm going to use when I'm factoring. When we use bottoms up, it factors into two binomials, r minus 7, r plus 9. Now, we're going to practice the bottoms up part just so we're familiar with it. But really, when a is 1, you don't have to do bottoms up. It's not going to be anything because you're going to divide by 1. But a is 1, we're going to do bottoms up. A is 1, so r minus 7 times r plus 9. Or if you did r plus 9, r minus 7, would that be against the law? Nope. You're multiplying. You can switch the order of things you're multiplying. So if r minus 7 moves to the right of r plus 9, so be it. We divide by 1, nothing cool happens or interesting. It just says r minus 7 and r plus 9. So that is our answer. Do we take my word for it? No, because remember this is reversing FOIL. So we can do the table or we can do FOIL. For you FOIL enthusiasts at home, I'll do FOIL this time. You know you're out there. R squared plus 9r, negative 7r, negative 63. Line up your terms, put them together. We get what we started with. It checks. It checks. That is our answer. I want to wrap up this lesson with two special pattern factoring. Just because if you can see these special patterns, it makes your life a lot easier. So I want you to be aware of them so you look for them when you're factoring just so you can move a little bit more quickly. I snap my fingers. Difference between two squares. The difference between two squares, the difference of two squares, you might hear it say, another way of saying it, I guess is what I'm trying to say. A squared minus b squared. Two terms being subtracted. A squared minus b squared, well, we can factor in a plus b times a minus b. The key is these two terms, the a squared and b squared, they have to be perfect squares. They have to be something that when you square root it, it comes out to a nice number, not 2.85756, some irrational number. So, let's try a problem here. Let's try x squared minus 25. Okay, let's try that one. Is that a difference of squares? Well, the difference means subtraction. Difference is subtraction. If I see two things being added, or, it's not adding a negative, then it can't be the difference of squares. We're done. All we can do is factor out a monomial, see if something divides each term. But I see this is a negative sign, so we have the difference part. Are x squared and 25 perfect squares? Well, x times x makes x squared. X squared is a perfect square. 5 times 5 is 25. 25 is a perfect square. So we look at the pattern. A plus b, a minus b. And we just plug it in. If x is a, then it's x plus 5. And b is 5. And x minus 5. We have just factored that perfect square. Okay? Now when we FOIL it, or we do the table, let's see what happens. X plus 5, x minus 5. We get x squared, 5x, negative 5x, and 25. I line up my terms. And the 5x's cancel out, and I get x squared, minus 25, not plus 25. We got a minus sign there. That would certainly change our answer, wouldn't it? but I did what I started with. X squared minus 25, it's that easy. Okay, let's do another one real quick. S squared minus 4. Is S squared a perfect square? Yes. S times S. And 4 is 2 times 2. So S plus 2, S minus 2. I'll leave T squared minus 121 for you. 121 is a perfect square. See if you can do that one. Okay? Last but not least on the special patterns is perfect square trinomials. Perfect square trinomials are ones that can be factored into one binomial that's repeated, I guess. A plus B times A plus B, or A plus B squared, or A minus B times A minus B, or A minus B squared. So these are what the perfect square trinomial patterns would look like. You have a perfect square A squared, B squared, those would be perfect squares on the first and last terms, and then the middle would be 2AB. So A times B, the square root of A, the square root of B, or the square root of A squared, the square root of B squared, multiplied together times 2, if it falls into that pattern. Biggest thing I look for is these patterns kind of get confusing, these equations get confusing, and please write them down. Are the first and last terms perfect squares? That's what I look for when I'm doing these. If the first and last terms are perfect squares, I can combine my bottoms up with perfect square trinomials and factor rather quickly. So if I was going to attack a problem like this, x squared minus 22x plus 121, and I was going to use bottoms up, I would say, okay, because, that's what's going to happen. In the reality, you're going to get to a problem, and I'm not going to say, ooh, look at its perfect square trinomial. You're probably just going to attack it with bottoms up. But just keep that in the back of your mind. As you're going through bottoms up, hey, do we have perfect squares here? So if I attack this bottoms up, it's A times C on the left, which is 1 times 121, which is 121. And what adds to make B, which in this case is negative 22. So x squared, is that a perfect square? Yes, it is. 121, is that a perfect square? Yes, it is. So what multiplies to make 121? Or what's the square root of 121? I would start there. 11 times 11. Well, 11 plus 11 is positive 22. So close, but not exactly what we need. So what do we do? Well, they have to be the same term, right? If it's a perfect square trinomial. So to get a negative 22 when we add them together, let's try making them both negative. This one's a no, by the way. The negative 11 times negative 11 is still positive 121. Negative times negative makes it positive. But when we add them together, we get negative 22. If you tried negative 11 and positive 11, that would be a difference of squares pattern because they would add to make 0. So you really can do bottoms up with difference of squares as well. Just an FYI if you really like to bottoms up all the time. But that works. That's our method. That's our combination. So we put this together. We end up with x minus 11 times x minus 11, or x minus 11 squared. Because x minus 11 times x minus 11 is the same thing as x minus 11 squared. Should we just leave it and assume that we're correct? Absolutely not. We should always, always, always check our answers. When you're doing these factoring problems or forming problems, you want to check them and double check them. You should be able to tell me before you hand something in or submit a test what you got on it. You shouldn't need me to check it because you've already done it. So when I list out my terms and line them up so I have like terms on top of each other, I end up with x squared minus 22x plus 121, which is what we started with, I believe. Let's go up and check. It is what we started with. It checks. This is the preferred answer. I wouldn't beat you up too much if you wrote it as x minus 11 times x minus 11, but if you want the ultra reduced, simplest form answer, you write it as x minus 11 to the second power, or x minus 11 squared. We're going to skip the other examples for now. We'll do some more work in class tomorrow. Real quick, let's revisit what our goals were for this lesson, what you were supposed to be able to do. Hopefully at this point you now can factor equations in the form x squared plus bx plus c, which you're solving down the road. You now should be able to factor equations with special patterns, difference of squares, and perfect square trinomials. We did both of those as well. We're going to continue factoring. Tomorrow's lesson will be when a is something other than 1, so we'll preview for tomorrow. Have a good day. One reminder I wanted to let you guys know is make sure that you have all these notes copied down, as I will be checking them again for points. So please, 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 please write everything down. Anything you miss, go back and check it over and get it down. See you tomorrow.